So without any further ado, let's have a programming lecture today. I'm excited. We're going to learn a language. Maybe you've seen it before, but we're going to learn it in depth. It's called Scratch. It's a simple language. It's all graphical. It's meant to be the first language that people learn. It's meant to be easy. And so we'll start with this, and then we'll transition into Python later. Okay? So if you would like, and I guess I'm going to force you to, please go to scratch.mit.edu. Okay, on your web browser after you sign in for attendance. That's where we're going to be working. And we'll eventually click this little Start Creating button. Feel free to click yours right now if you want. Scratch.mit.edu is a magical place. It's a new programming language invented by some smart people. And when you do click Start Creating, that creates a new program for you. And there's a bunch of cool stuff going on. And by default, you get a few things. Like these are little Lego blocks you can drag out. I'll show you more of that later. And then over here, this little window is where your program gets run. This is called the Scratch Cat, by the way. So he's like the mascot of the Scratch language. He has his own wiki page. He's got his own lore behind him. But yeah, he's cool. You can read more about him if you want to. But he's called a sprite. It's a little object that you can interact with and cause to do things in our program. So a lot of the programs that we're going to be writing in Scratch will be animated programs. Okay, that's kind of cool. So it's easy to make little games. Yeah.
What's the website for the?
Oh, it's www.lottensclass.com. I don't know if you can see that, but it's also on our Canvas homepage at the bottom. Whee! Is the door not opening over there? I tried to tape it open. All right. So let's see, where were we? Over here. So yeah, this is the Scratch Cat is a sprite. We'll have him do cool things. All right. So I'm gonna just give a demonstration pretty much for today, and then I'll also ask you guys to play around too. So look forward to that. Try to follow along if you can. It's okay if you can't. I'll come help you later as well. But yeah, just ask lots of questions because maybe you've never programmed before, and I'm here to help. Okay. So yeah, here's what we're doing. Well, let's get started. Let's make it happen. Let's learn how to program. So what is a program? If we've never programmed before, what does it all mean? All right. So a program is honestly just a recipe. So if you've ever made something by following a recipe, you've run a program before. If you've changed a recipe, you've technically been a programmer before. So that's kind of cool. Programs are made up of little tiny pieces that we call algorithms. So an algorithm is just a little sequence of steps to solve a problem. It's a little mini recipe in a bigger recipe, let's say. And so let's be programmers for a second. Let's say that I have amnesia or something, or like I'm an alien and I've never heard of a peanut butter and jelly sandwich before. Could someone please write the program for making a peanut butter and jelly sandwich? Tell me what it is. What's the recipe? How'd you do it? Yep. Exactly. What's step 2? There you go. All right. Anybody else? It's not ready yet, is it? That's okay. Something about mathematics?
So I think my program understood math part.
Oh, okay.
And going down in another place for array or method that will solve it.
Nice. So yeah, if I were you, if I've never programmed before, probably my recipe would be like, all right, get some bread and put some peanut butter on it and then put some jelly on the bread too. Yeah, voila, peanut butter and jelly. Let me pretend to be a computer now executing your program to create peanut butter and jelly. So here's what would happen if I were a computer. All right, let me get my pen larger here. So, okay, your algorithm to make a peanut butter and jelly sandwich is get some peanut butter, get some jelly, put it on bread. So here is my best three-dimensional drawing of a bag of bread. Whee! Little slices up in there. And you said, okay, get the bread, and then put the peanut butter on the bread. So there's a peanut butter jar, and I have stuck it on top of the bag of bread. So I'm the computer. I'm running your program. That's what you told me to do. And then here's the jelly jar. You said put that on the bread too. So there you go. I have just run your peanut butter and jelly program. Voila! I, as the computer, have just made a peanut butter and jelly sandwich for you. That's exactly what you wanted, right? Highly doubt it. You don't want to eat plastic, probably. So what just happened? So computers, they're very, very smart. They can do a lot of cool things very quickly. They're also very dumb. You kind of have to talk down to a computer when you're programming it. Computers can only understand little bite-sized instructions that they know how to do well, okay? You get into trouble if you try to zoom out like this that we've been doing, okay? So as a computer, I would follow your instructions to the letter. And so we have to break this problem down further if we wanted the computer to really understand it, okay? So we want to think like a computer, write our recipes at the level that it can understand, and that is called thinking computationally, all right? Computational thinking is the idea of thinking in little small steps that are super specific, that the computer can understand, and there's no ambiguity. Okay, so that's going to be the goal for this class. That's what I'm going to teach you. So a better recipe, let's say, for peanut butter and jelly sandwich would be, okay, get a plate, get some bread, get the bread bag out, get 2 slices of bread, put them separately on the plate. Go get a knife out of the drawer, put the knife in one of your hands, and then open the peanut butter jar with the other. Take the knife, stick it into the peanut butter jar, get some peanut butter on that knife, and spread it on one of the pieces of bread. Do the same with the other slice and the jelly. And then stick the slices together where the peanut butter touches the jelly, right? Because you could totally do it the other way. And you have to be specific, right? There's ambiguity there. So that's what you're going to learn in this class during the programming lectures, right? That kind of thinking. And it's exciting. I mean, it's my career. I'm enjoying it. So I hope that I can pass that along to you too. So we're going to learn Scratch. It's our first language that lets us think computationally. A bunch of different steps. Okay, so Scratch works like this. On the left, you've got all of these little blocks, we call them, and each of them can do one step of running a program. So turn 15 degrees block, if you drag it out, you can click on it and it kind of runs that block and it affects the current sprite. So right now, the Scratch Cat is called Sprite 1. You can change his name. Call him Scratch Cat. Whatever you want. But this window is where your program will run. All right. And so this block, if you click it, it's going to affect the Scratch Cat. And you see, if I click it once, he's turning 15 degrees. And if you look really closely, it's affecting a little piece of him down here at the bottom. He's got a name. He's got coordinates. There's a coordinate system deep down. So like here's 0, 0-ish is in the middle of the screen. Here's X getting big, Y getting big, negative X and Y, stuff like that. So you can see that the coordinates are changing. You can change this, like whether or not the Scratch Cat is hidden or shown. You can change his size, make him a giant cat. A little too large, maybe. 150 size or whatever. And then he also has a direction, which is the way he's facing. So by default, he was facing direction 90 degrees. Okay, and that was facing to the right. So yeah, it's a little bit about what you can do in Scratch. And your programs affect, this program is associated with this Scratch Cat sprite, we say, because he's selected right now. We only have one sprite in our program. And so if I click this block, it affects the Scratch Cat and he turns 15 degrees. You can drag the other one out and make him go back to normal. Okay, so our goal is to chain these blocks to do cool stuff. Because if you chain them, it'll do multiple things. All right? Here's kind of how Scratch blocks will work. You drag them out into your program window, and they work like this. Like you got the first one, it does operation 1, like turn or something. And they all fit nicely into each other like a Lego, like Lego pieces. So that does operation 1, then you can put the next one underneath that, and it does operation 2, and then you put another one underneath that that does a third thing, like maybe you change its color or something. Like you can do all these things, and they happen in order. So when you run this program, you click this big set of blocks, it'll run from top to bottom. It'll do this thing, then this thing, then this thing. Okay, that's what's going to happen. And so they'll all get run in order, all right? And another word for run in computer science is execute. It's not like you're murdering your program, but that's just the technical term. We execute the program. These blocks get executed in order, all right? That's the idea. So execute is just a synonym for run, okay? In this context, at least. So yeah, that's how Scratch is gonna work. So for example, I can be like, turning and moving, move 10 steps, is going to move the Scratch Cat in his current position, his current direction, sorry, which is to the right, 10 units. And so his X is going to force his X to be 10 units bigger. See how the X is changing? Whee! Because that's the direction he's trying to go. If his direction was up, it would change the Y, of course. So move 10 steps in your current direction and turn 15 degrees. If you want to do both in some order, it's like pick the order. So now he's going to move 10 steps in his current direction and then turn. So if I click it, it'll run both of these now. All right, you see it? See it? Whee! If I click it, he's like walking around the moon or something. And you can change these, like move 20 steps. That's going to make him move a little bit more. And then also turn 15 degrees. Oh, something weird just happened, sorry. Something weird happened to my computer. Did I run out of memory? Sorry about that. My screen went blank. Okay, it's back now. Whee! So now he's moving 20 steps and then going 15 degrees. And so it kind of makes him walk around an invisible circle, which is kind of cool. And so like scroll down, find some cool things. Look at them. We're gonna use a lot of these in this class, right? So hopefully that makes programming seem less scary. You've never done it before. But for my first trick, I'd like to make a program called Hello World. If you've never been a programmer before, it's customary. They would take my computer science license away if I didn't do this. I have to give you a program that outputs Hello World to the screen. It's like you're causing your program to be sentient. Okay, that's the idea. It's like talking back to you. That's the goal. And so I'm going to write a program where the Scratch Cat is going to say to us, "Hello World, I exist." Like we're getting him to do our bidding or something. All right. So let's go and look for the block. Does anybody see it? First of all, if you don't like the blocks that you have out, you're done with them. You can drag them back, or you can go to delete. Right-click delete. But does anybody see, if you scroll down, a block that might have the Scratch Cat shout out something? To say something to us. Anybody see it? It's not currently visible. You gotta scroll down. But yeah, think about that as I get this guy back to normal. 0, 0, direction 90. Cool. So we're all asleep today. It's the say block. You see it? Say hello for 2 seconds. Or just say hello. But I like this one because it makes him stop saying something. So for 2 seconds, he will have a little bubble, and he'll say hello when I click this block. That's kind of cool. And so I want him to say not just hello, but hello world, first of all. Hello world. And that's the program, right? We did it. Does that make enough sense? The block that does the thing that we want to do. Okay? That's the goal. This is kind of cheating, though. All right? So this is a program. It's technically correct, but only technically. So really in Scratch, we'd like the program to start not when we click the blocks. We'd like them to start in a well-defined way, and that way is called an event. We'd like an event to start off our program. All right, clicking that block is just like good for testing. It's kind of cheating though. So what we'd like to do is click this little green flag and have that hooked into our program. When I click the green flag, I'd like it to start running. Okay, so if you go down to events, you see actually kind of nice the way they did it. You see that there can be nothing above these things, right? Whereas these blocks, like things can hook in above and below. These start computations, all right? Nothing can happen before them. So this is an event. When the green flag gets clicked, it will run everything below it. You see that? That's how you read that. So that's what we want here. That's an event, and it will start a computation, all right? Events can't have anything before them, so they start, all right? That's the idea. So now when I click this green flag, it will run everything in here. Isn't that cool? And then we can add on to it. We can say, all right, in addition to doing that, move 10 steps and turn 15 degrees after you do it, right? Because it's in order. So he's going to say hello world for 2 seconds, and then it'll do that movement. See that? That's the goal. Okay? That's pretty nice. So, in addition to that, I would like to just leave notes for you guys. So, as a programmer, you're going to save your program, and you're going to come back later, and you're going to forget everything you did. So, it's nice to leave little sticky notes for yourself in your program, and those are called comments. All right, it's not real code. It's just a call to comment, and you can right-click on any block and leave yourself a little comment. Add comment. And it leaves a little sticky note for you. You can write whatever you want here. It's just for you. It's not part of the code. You're like, all right, this block says, it's self-explanatory, but this is just an example. This block says hello world for 2 seconds before it's finished and the rest of the program continues. All right. So that's called a comment. Click the little green flag. It runs the program. And yeah, that's the idea. Okay. So, any questions about this? I'm going to give you all this code that I write today. And I definitely want you to play along too. So here, let me save this so I can give it to you later. And those of you who joined the class a little late, make sure to do attendance. I'm going to keep that running for a little while. Make sure to get marked here. And then what we're working on right now is a place called scratch.mit.edu. To bring the computers up, there are buttons by your desk. There's an up arrow. Just hold in that up arrow. All right? And we're going to scratch.mit.edu. That's where we're working right now. All right. So, yeah, you got the program eventually. And, yeah, are there any questions before I do something slightly more complicated? All right. So, let's keep on trucking. Let's have a program that's a little bit more complicated. Let's have a program with some animation involved for real. So here's my silly little setup. Let's make a program where the Scratch Cat is hungry and he goes to the fridge and he wants a banana for some reason. Apparently I think cats can actually have a little bite of a banana. I've seen that before. My cat does not like bananas though. But technically I think cats can eat bananas, so I think it's fine to do this. And he's going to walk to the fridge, get a banana, and then walk away with the banana. All right? That's the goal. So let's set this up in Scratch. So I'm going to go to File New to clear out my program. You can do that too if you want. But everything's back to default now. The Scratch Cat is called Sprite1. We can name him back Scratch Cat if you like. And there's also, in addition, there's a few buttons on the bottom here. This button is called Choose a Backdrop. I'm going to click that because there's a refrigerator backdrop apparently. It's just like a scene. It sets the scene. So I'm going to scroll down and I'm going to find either kitchen or refrigerator. I don't honestly remember. There is a refrigerator one. Isn't that fun? So here's a refrigerator backdrop. That was this button. And then also, I want to be able to move things around. The Scratch Cat is a sprite, and then the bananas. There are bananas too. Those are also sprites. So down here, choose a sprite. If I click this little button, I can search for bananas. And here are some bananas that I can just drag into the fridge. So that's kind of nice. So that's part of our program now. And every sprite has a coordinate, right, associated with it. There's a coordinate system underneath in our programming language where 0, 0 is the middle of the screen. If you see if I drag these bananas, you'll see that their coordinates change. 0, 0 is smack in the middle of the screen. All right, so we're going to, in our program, change those coordinates to have animation happen. All right, that's the goal. So let's start off the bananas over here and the Scratch Cat over here. And what I would like to do is bring him over and have him walk away with the bananas. All right, so let's come up with an algorithm to do that. Let's make it happen. So here's my silly idea. All right, let us start the bananas in the fridge. That's where they begin their life, like they are right now. Cool. It's when the green flag gets clicked, bananas over there, Scratch Cat far away, and then we're going to move the Scratch Cat towards the bananas. Does anybody see a block that might be good for that? There's a couple, right? There's change your position blocks. There's straight go to a certain coordinate. So if the Scratch Cat's over here and we want them to be at -175, -84, it's kind of nice because you see how these are changing. It's go to wherever you are right now, which is cool. So this is a go-to block. If I drag the Scratch Cat away from where he was and click it, he'll go back there. He'll just warp right there. But I'd like him to walk, or at least do a moonwalk kind of thing. So the glide block is a better one for that. So glide and take 1 second, Mr. Scratch Cat, to, let's say, here. And what is that? Negative 164, negative 76, something like that. And if you didn't want to take the time to like do that and type it all out, remember, then you just like move the scratch cat to where you want him and then take out the glide block. See that? And then move him back. And then if you click this block, so he'll take a second to glide over there. Isn't that cool? So let's say he's hungry, he's famished, and so he can't walk that fast. Let's say he's going to take 2 seconds to glide over there. Whee! All right, so that's kind of what I want to have happen for the scratch cat. And the first thing I want to show you about this is the scratch cat's program. Like I said, you see how the scratch cat is selected right now? He's highlighted. This block applies to him. All right, not the bananas. The bananas are a separate sprite. They can have a separate program. You see if I click the bananas, that block went away. That block was not associated with the bananas. It was only part of the scratch cat's program. Do you see that? That's important to understand. So the bananas are they need to stay still for a second, right? And then they should walk away with those, with the scratch cat. So yeah, the scratch cat's gonna walk over here, and then he's gonna walk back. All right, that's kind of the goal. And so let's make that program at least. So when the green flag gets clicked for the scratch cat, what do I want him to do? I want him to be over here and then glide over to that fridge and then glide right back. All right. So some things are missing right now, first of all. But what will happen right now to the scratch cat if I click the green flag right at this moment? Can anybody tell me? Will it work? So I think something's wrong. If I click the green flag right now, it's going to run this block. Is it going to do what I want it to do? He's going to take 2 seconds to glide to where he is right now. You see that? That's useless. And so when the program starts, we kind of want to reset everything. Does that make sense? So when the program starts, I'd like the scratch cat to like warp over here. Make sure you are here to start, please, because then we can have a real program. Does that make sense? So that's where we're going here. So at the start of the program, you better warp to, this is fine, go straight to here. See that? So if you weren't there already, put him up there, you will start out there always now. You see that? That's much better. So he's over there, and then let's say that he's holding on to the bananas now, and let's have him walk away right back here with them. And so take another 2 seconds to glide to this new spot. All right, so that's the scratch cat's program. Does that make sense? Any questions about that? That's kind of what I want the scratch cat to do, and then we're going to have to deal with the bananas. All right, and if you want to stop your program halfway, there's that stop button. He'll just stop. And this is always going to work. He's going to get reset to the side always, no matter what. All right, now I just need to make him walk away with the bananas, yeah? All right, so the goal for the bananas now, what do we want the bananas to do when the program starts? So again, when the green flag gets clicked, bananas, what are you doing? They need to glide away with the scratch cat, yeah? That's the algorithm. So they're over here. They need to glide over here and take just as long as the scratch cat took to get there, so also 2 seconds. So bananas end up over there, so whatever your coordinates are right now, and take 2 seconds to glide over there. You see that? Take 2 seconds. You start over here, take 2 seconds to glide over there. So I'm going to click it. This is what the scratch cat's doing. Starts here, glides over 2 seconds, glides back 2 seconds. And then here's what the bananas are doing. They're going to glide over here when the green flag gets clicked. All right. Is there anything wrong with this? What do you think is going to happen? Play it in your brain. Boop. The bananas just hovered and went over there of their own accord. They're haunted bananas now. Because when the green flag gets clicked, the bananas run this block. That means glide right over, right? They're not waiting for the scratch cat. You see that? Because the scratch cat took 2 seconds to get over here because that was his program. It's like, all right, take 2 seconds. This first block was just warp instantaneous. Then he took 2 seconds to get over here and 2 seconds to get back. So the bananas, what do they need to do? They better wait 2 seconds to start moving. Then and only then will the scratch cat be there. See that? That's the goal. All right. So there is a wait block. It's in control. So for the bananas program, you better wait 2 seconds, and then the scratch cat will be where you belong, all right, where you are, and then you can glide back with him, and it'll look like you're hand in hand. All right. So now when I start the program, bananas are waiting, and then they start gliding. Does that make sense? Any questions about that? Please just shout out if you have questions about any of this stuff. It's kind of fun, right? So again, let's remind ourselves. Let's use a comment to say why did we wait 2 seconds here? So it takes 2 seconds for, oops, can't see anything, for the bananas, or for the scratch cat to get over to the left side by the bananas. Something like that. And that's reminding us why we did this wait block. That's useful when we come back later and get confused. All right. So here's the scratch cat's program. Starts out over here, goes there, glides back. Here's the bananas program. Waits 2 seconds, glides to over here. Do I have a similar problem to the one before? If I click the green flag now, is it correct? Is it going to do what I want to do? What's going to happen? I claim something is wrong with the bananas right now. Good. Yeah, so the bananas right now, what is it doing? It's just doing these things in order. It's following it to the letter like the peanut butter and jelly. Bananas will wait 2 seconds and then glide to this spot, and they're already there. So they're doing nothing at all, really. And so we have to start the bananas back in the fridge always. See that? So, hey, bananas, always, when the program begins, you better warp straight to the fridge. So start the bananas out in the fridge. I'm so sorry. I have no clue what's going on. This room is haunted already. I'll have to talk to somebody about that. But yeah, it's like start the bananas out in the fridge. And then the scratch cat also, oh gosh, I didn't want to duplicate. Another comment, start the scratch cat outside the fridge, on the right side of the screen. Start the scratch cat outside the refrigerator. Right, on the right side of the screen. This is just me leaving little sticky notes to remind myself what was going on. All right. So I think we finally have a correct program. When the green flag gets clicked, these things are happening to the scratch cat. And then when the green flag gets clicked, these things are happening to the bananas. Whee! So the bananas are doing the right thing now. If I rerun it, they're going to warp to the fridge. And we have a working animation again. And then the scratch cat was right all along. He's like going to start out over here, warp over, glide over here, and then glide back. Right? And take 2 seconds to do it. So it's important to align this stuff. So if the scratch cat only took 1 second, then the bananas only have to wait 1 second. You see how there's some cooperation involved here. So essentially, we are running 2 programs at once, which is honestly something that I don't even teach my computer science major students until their last class here. So you guys are learning very, very powerful things right now. Multi-threading. So, yeah, I'm going to save this so you can have it later. Are there any questions about this program before I give you another one? One last, more complicated example. Have we all done attendance, by the way? Can I stop that now? Speak now if you have not done it. Get marked wrong, marked not here. Going once, going twice. Thank you. So yeah, very good. Close that Wikipedia page. Here is my silly last example. Let's have the scratch cat getting abducted by aliens. All right, that will be my pièce de résistance for the day. So what we need to do is complicated. We have to make a UFO come down, send a beam out, bring the scratch cat up, and have the UFO fly away, something like that. That'll be the algorithm. But I do want to teach you a term first before we get there. The thing that we did here, where we started the scratch cat on the right side of the screen, started the bananas in the fridge, there's a term for that. It's called initialization. We gave initial values for the bananas and for the scratch cat in terms of position at least. Right. So we say that we initialize something when we give it a starting value, an initial value. Right. So we initialize those bananas. We initialize the scratch cat's position. Okay. So that's an important term now, and so I'll be using that a whole lot from now on. All right. So here's my little algorithm idea for my alien abduction example. All right. So we need a UFO. It needs to, like, here's the scene, set the scene. The UFO needs to appear, like the warp drive stops and now it's suddenly in the atmosphere. And then the UFO needs to kind of like move on down closer to the ground because it needs to send out its little tractor beam or whatever. It'll send it out. And then the scratch cat, just standing there aimlessly, unfortunately, will start gliding upwards into the beam and close to the ship. And then I'd like the cat to disappear. He needs to hide himself, right? There's a concept of showing and hiding now. We're going to make use of that. And then the beam also needs to disappear because it's done its job. And then the UFO needs to fly away up into the atmosphere. Okay, so that's kind of the algorithm. And so there's a bunch of different moving parts. Like, what do I need to be sprites? The scratch cat needs to be messed with. We need a UFO sprite, and then we need a beam sprite because it needs to be shown and hidden. Right? Things that your program interacts with need to be sprites. The scene itself can be a backdrop. All right. So I'm gonna go to File, New, clear this all out, and I've got my scratch cat. Let's give him his real name. I don't know. I like it. I like doing it. And I'm going to add a backdrop. I think there's like a cornfield backdrop, something like that. Hayfield. This is the perfect scene to get abducted by aliens, right? So here's the scratch cat down here. And I need like an alien spaceship. So let's add a new sprite for that. I don't think there's exactly an alien spaceship. But there's like a rocket ship. We'll pretend it is an alien spaceship. All right. Dun, dun, dun. So let's pretend this is not from the Earth. All right. There's my little rocket ship, and then let's say it's going to come down here and send out its beam, just like that, maybe. Let's have it shown like that, maybe. And then there is no tractor beam for alien abduction sprite, so we need to make one. All right. So instead of choose a sprite, this button, I'm going to move my mouse on up to the paint button, and I can make my own new sprite. And so it opens this little editor thing. And I'm just going to draw with these lines a little, what is this shape? This thing. Is this a rhombus? I don't remember, honestly. Something like that. And then I can fill it in with like purple, and that'll be my little beam. All right. We do need to make it see-through, though. All right. We do need to make it see-through, and we'll do that in a second. So we're right now, this is called Sprite 1, and I want to call it something with a name, a real name. We'll call it Beam instead. So now it's Beam after I hit Enter. And it needs to be see-through. I think that's important to how this works. So if you go to the code for the beam, so here we were in the drawing page, that was the costumes tab. Back to the code tab. For the beam itself, there's a way to make it see-through, all right? And that has to do with, I think it's looks, makes sense. So that's going to be, if I scroll down, there are different effects you can change. Like you can change the color effect, which like warps the color, which is kind of cool. Put it back to normal if I click it enough. But I want to change the ghost effect, and that's transparency. It makes it look like a ghost. Okay? So that's my goal. And if I, let's not change it. Let's set it. Let's set the ghost effect to like, it's like a percentage. 0 ghost means perfectly visible, perfectly opaque. And then like 50 is 50% transparent. So now if I click the block, I get a little see-through beam. See that? And so that's going to be the goal. All right. So any questions so far? We've got most of the setup. We just need to hook it all together now. What do you mean third thing? Where? This beam? So we drew it. So I went into Paint and I drew that beam. I used the little fill tool to fill fill it in after I drew some arrows. So yeah, so now we've changed its ghost effect. And so all of these things need to be working together as a team because they're our program. And so I'm going to drag out that green flag into everybody. For the Scratch Cat needs some stuff. The rocket ship needs some stuff. The beam needs some stuff. So we already have one thing for the beam to do, right? Become transparent. But actually, some things need to start out hidden, don't they? So there's some blocks for that. I think it's in looks. I would expect it to be in looks. Each block, each sprite, you can control with these show and hide blocks. So show, make sure the sprite is shown if it's not already, and then hide, make sure the sprite is hidden. Right? So at the start of the program, we want the Scratch Cat to just be unaware of everything, right? Not aware of his fate. And so we better start the beam out for sure hidden. Yeah. Again, I'm very sorry about this. I don't know what's happening. I'll have to send somebody a message about this. So sad. But yeah, so the beam starts out hidden. Same with the rocket ship. That's like the UFO, right? It should totally also start out hidden. Yeah. That's the goal there. And then the Scratch Cat can start out visible. And so when I click the green flag, or they make sure to be hidden, right? Rocket ship stays hidden. The beam is hidden and make sure it's transparent. And then we're going to eventually show those things, okay? So let's go back to my algorithm, what were we planning to do. We want the UFO to appear. That's the very first thing that should happen, is the rocket ship should appear in like the upper atmosphere. So let's say he's up here, and he kind of needs to glide down to here. So let's make sure he starts out up here. Yeah? All right, let's pretend I forgot to say that. And let's say he starts out up there. He needs to eventually glide down the rocket ship to approach, to beamable distance. So let's say here. Let's say it takes a second to glide, little rocket ship. Dun, dun, dun. Where do I want it to be? Take 1 second to glide down to there. Okay. Dun, dun, dun. So glide down to there, and you should also be shown when that happens. So technically, we can actually start out the rocket ship shown, if that makes sense. That would work. Make sure you are visible, little rocket ship, because hiding and then showing, these two things happen instantaneously. You're just never going to see it hidden anyway. So the hide can kind of go away for the rocket ship at least, but the beam definitely needs to start out hidden. All right, so the rocket ship's up here, hidden or not. It's going to show itself and glide down. Show itself and glide down. Right? So I keep clicking this green flag. We see that there's a problem with the rocket ship, right? It needs to start out up here. It needs to be initialized, so it can like come down into the atmosphere. Okay, so let's initialize our rocket ship to be. Let's warp it to sort of up here if it's not there already. So please, little rocket ship, warp up there, show yourself, and then come down to Earth if you're hidden. Maybe you're not yet hidden. All right, but if it was, it'll make sure start it up there, show itself, glide down, even if it was hidden. All right. So that's the rocket ship's program so far. Any questions about it? Make enough sense so far? Cool. And then it needs to send out that beam, right? So now it's the beam's turn, all right? Boop. Now the beam should come out. It should show itself, yeah? But only when the rocket ship gets down there, the beam needs to show itself. Sorry, that's in looks. Show itself. So how long, my question for you is, how long should the beam wait on the rocket ship until it's ready to show itself? Because it needs to wait, right? It shouldn't immediately show itself because the rocket's not in position yet. How long does it take for the rocket to get down here? Because that's when the beam should come out. If this is the rocket ship's program, can you read it? Can you read it out and see? 1 second. Very good. Every block, this is my secret for you guys to know now. Every block that has no amount of time associated with it, I want you to consider it instantaneous. Right? This block happens instantaneously. This block happens warp speed, blink of an eye. This is the one that actually takes time. So all of these blocks in total, this takes 0 seconds, this takes 0 seconds to run, this takes 1 second. So it's taken 1 second for the rocket ship to get into position. Good. And so 1 second, that's in, is it control? that that beam better wait 1 second and then show itself. That's the right order. You see that? Because it's going from top to bottom. That's the right order. Let's remind ourselves of this. So it takes 1 second for the rocket ship to get into position. All right, so that's what we're waiting on. Then we show ourselves with that beam. So this is the beams program. Whee! That's perfect. See that? Could have drawn the beam better, but you get the idea. It starts out hidden, it's moving on down, and then it's sending it out. So that's the beams program, the rocket ships program. They're both doing the right thing now. All right? Any questions about the algorithm so far? You still good? What? So I drew that beam. I did those paint buttons. So now what needs to happen, right, is the scratch cat needs to get beamed up. So he needs to glide upwards. Now that the beam is shown, the scratch cat needs to glide up into like right here, let's say. So the scratch cat's program, he needs to glide, take a second to do it, that's fine, up into the rocket ship, but when is the question? Only once the beam is ready, right? Does the cat need to start gliding? Yeah? So how long does it take for the beam to come out? Here's the beams program. Somebody tell me. Again, 1 second. Good, yeah, everything else is instantaneous. It takes 1 second, and then the beam shows itself. Does everyone see how we're reading that? That's important. Good. So the scratch cat is waiting on the beam. That's going to take 1 second, and then he can be beamed up. All right? It takes 1 second for the beam to come out. Okay? And so that is looking a bit better. It's going to get beamed up there. If I click the green flag again, I think you know right now what I'm trying to say. There's an issue with the scratch cat. He's not initialized. So when the program starts, the scratch cat needs to be down at the bottom. Let's make sure he's warped there at the beginning of the program. So go to little scratch cat. Warp right there. Make sure you're in position. Initialize yourself. So we're initializing the scratch cat. Whee! Get beamed up. Wait a second, get beamed up. All right? We still good? We're getting there. So now that the cat has been beamed up, he should be like warped inside of the ship. And so the beam should disappear and the cat should disappear. All right, so took the scratch cat that long to glide up. Now he should disappear. Hide yourself. And then we also have to hide the beam after it's beamed up the cat. But there needs to be something in between, right? Because we're waiting on the cat right now. The beam should be waiting on the cat to glide up into the ship. How long does that take? How long does it take for the cat to be beamed up? 1 second. Good. So that was right here, right? Is this gliding? This 1 second gliding. The beam is, after 1 second, the beam is there. And then it takes 1 second, the beam should stay there. And then you're ready to glide up. See that? That's important. That's another wait 1 second. Now we're waiting on the cat. And then we can hide ourselves as the beam. All right? It takes 1 second for the cat to be. So we should show ourselves. You see how these 3 blocks together, you can take them as the beam is showing itself for 1 second, because it's in between. Show, wait, hide. Can you kind of imagine what's happening there? It's only going to be shown for 1 second. All right? That's the goal there. Whee! So that's the beam, waiting a second to show itself. Then the scratch cat gets beamed up. And oh no, there's another initialization issue. The scratch cat is eventually becoming hidden, and when I restart the program, I didn't say otherwise, he stays hidden. So we also have to initialize the scratch cat to show himself at the very start of the program. Yeah? That's also important. That is, make sure once you're in the right position, you're always shown if you aren't already. See that? Whee! So now he's always going to be hidden. And then the beam is going to stay there for a second and go away with the cat. Yep. All right, last piece of the puzzle. Now the rocket ship needs to fly away, at least up into the upper atmosphere. That's the goal. How do we do it? We have to make the rocket ship glide up. So let's say that like there's a good spot, and we will glide him there, glide the little rocket ship there, but not immediately, right? Because it takes time. The rocket ship needs to be down there, right there, for a while, and then glide up, right? As long as it takes for the Scratch Cat to be beamed up. Yeah. So again, my question, I think I can do the answer this time. How long does it take? How long should the rocket ship stay right there? It's going to be 1 second again, all right? Because that's how long the beam is being shown and how long the Scratch Cat is taking to glide up into the ship. Once they both hide themselves, everything's good, you can start flying away. Your cargo is intact, yeah? So it's going to take 1 second for that beam and that cat to do their job. And that's how long the rocket ship shouldn't do anything, and then it can fly away. Yeah? Whee! There it goes. So wait a second. It takes 1 second for the cat and the beam to do their thing. Beautiful. And then if you want to, you can have the rocket ship like put on the warp drive after that. You can have it hide itself. That's totally possible. Goes into warp mode, hides itself. Now it's only the rocket ship on the screen. I don't have to deal with anybody else now. Now I can just like do the rocket ship's program at the end there. Boop, blink of an eye gone. Isn't that nice? That's our program. So here is the Scratch Cat's program. Let me try and explain what's going on with all these guys. So as far as the Scratch Cat is concerned, what he needs to do is start at the bottom here. That's that go-to block. And then make sure he's shown, because he got beamed away in previous versions of the program. So he might not be visible right now. And he isn't for us. Start out right here and show yourself. And then wait a second, because we're waiting on that rocket ship to glide down. Wait a second, and then the rocket ship and the beam are in position. And take a second to glide up. Take a second to glide up, change into those coordinates, bring yourself into the ship, and then hide yourself. Because then you've gotten beamed up. That's the Scratch Cat's program. The rocket ship's program, make sure you're up here in the upper atmosphere and shown, like your warp drive, you just turned it off, you're in the upper atmosphere. Come down, you're shown, glide down into position, and then wait on the beam and the cat. Wait on the beam and the cat, wait 1 second, and then you're ready to glide up again, turn on the thrusters, and then turn on the warp drive and hide yourself after that. Right, so that's the rocket ship's program. Again, it's all in order. And then finally, the beams program. Starts out hidden, takes a second, right? Make sure you're transparent as well. Take a second for the rocket ship, wait a second for the rocket ship to get into position, because then we're going to send ourselves out, show the beam in that exact spot. We're never changing the position of the beam, by the way. It's always in that same spot always. We never have to deal with that. Wait a second for the cat to be beamed up, and then hide yourself. So these last 3 blocks, they kind of, I see them as, show that beam sprite for exactly 1 second. That's how I think of it. And then your job is done. All right, so those are the 3 pieces of this program. There's a lot of moving parts. There's a lot going on. I know. I'm going to save this, and I'll give it to you after class. It'll be in the Code from Class link. But yeah, are there any questions about any of this right now before I let you do something? I have a little mini assignment for you guys to play around with. All right, so we got some time. So here is your in-class exercise for the day. Please help each other as well, right? Show each other your cool stuff. But I'd like you to, if you haven't already, recreate this. Here is every piece of code. I'll make it all visible for you. All right, so here is the Scratch Cat's code. Now let me do it where you can kind of see them. Take a screenshot where you can see that little transparent image of the Scratch Cat. So now you know it's his code. So that was the Scratch Cat's code. And then here is the rocket ship's code. Put it over there. I'll make this all pretty in a second. And then here's the beams code. So let's make this all pretty invisible. Get rid of whatever this is. And so we have plenty of time, and I set it up this way for a reason, because the best way to learn is to honestly play around, show each other your cool stuff, and get help from either me or your peers. So here's everything. If you want to cheat, here's all my code. I'd like you to get it working this way, first of all, if you haven't already, and I'll come around and help if you're having any issues. But then after that, I want you to change this. Play around. Try to change the code for this program to have like the scratch cat running away safely. Like have him glide very quickly somewhere else and have him like yell obscenities because we know the say block now, right? Have him just like shout curse words at the rocket ship as he's running away. We can do that, right? That is a program that we can write now. We know those blocks. We know how to glide that scratch cat away. We know how to make him say stuff. Like you can do that. If you want to get super fancy, you can make a new sprite for like an explosion to have like the scratch cat blow up the rocket ship and have that show itself at the proper time. The possibilities are legitimately endless. And that's the beauty of programming. So, yeah, do something cool, and I'll set a timer for like 10 minutes, and then we'll come back. All right? And I'll be here to help. So, yeah, if there's something you want to do that you don't yet know how to do, I can help with that too. But yeah, hopefully this is a little taste of what you could. Just clicking a block. What does this one do? Let me click it. How would it affect my current sprite? All right, a couple more minutes, and then we will continue with the lecture. I hope we did something cool and you enjoyed that. It was fun. It was fun to play around. So there's plenty more time for that. Let me just wrap things up on my end and let you guys hang out until the end of class after that. So I want to give you your first programming assignment now. All right. So, dun, 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 did I save 3 files? I did. So I did save this one. Good. So on Canvas, I'm going to give you your first programming assignment. And for computer science reasons, our programming assignments will start numbered at 0. So this first programming assignment is really programming assignment 0. All right. We start things at 0 in computer science. It's just a thing. So, dun dun dun. There are 2 different assignments, like I said on the first day. Either you have programmed before or you have not. All right. If you have never programmed before, I want to give you a Scratch-like assignment. All right. If that is you, I want you to do this thing called Hour of Code. All right. So I want you to complete any Hour of Code activity on this website if you've never programmed before. All right. This is your assignment. You're gonna go to this website and you click any of these. Like there's some cool like Minecrafty looking things. There's some music generation programs that you could write. But any of these, pick one. You can make a game. But yeah, it'll teach you in a Scratch-like way to walk you through a program, and I just want you to complete that. And once you get to the end of the lesson and you have your final game or whatever, it'll either show like you've completed everything, or it'll even give you a little. Sometimes it gives you a little image of like a certificate. That's what you'll be turning in, some sort of screenshot showing me that you finished it. All right, either show me that certificate that it showed to you once you finish, or like show me that you're on step 10 out of 10 or whatever. I want to see all your code blocks too. All right, so just give me an entire screenshot, show me all that. Okay, or maybe 2 if you can't show me all those together. So if you have never programmed before, that is your assignment, and that's what you'll be turning in next week on the 22nd. So another week and a day. Okay, so usually I'll have like writing assignments due on Tuesdays and programming assignments due on Thursdays. Okay, so you got plenty of time to do it, but that'll be your assignment if you've never programmed before. Okay, does that make enough sense? All right, if you have programmed before, that's going to be a little too easy for you, and I want to make sure you're doing the same amount of work as the other students to keep things fair. So I have 2 different things that you could do, or honestly many different things that you could do. If you just want to do what I want you to do, if you just want to like follow my instructions and not think of anything yourself, here is your assignment. All right, here is a cool little book. It's called How to Design Programs. Even if you programmed before, it's worth reading. I promise. You click the book, it takes you to chapters, and you'll be in part 1, these first 2 sections of chapter 1. And of course, the display is unhappy again. That's so weird. Might just have to either restart this box down here or restart this computer. That usually fixes things. But yeah, here are the 2 sections, 1.1 and 1.2. They'll teach you a weird programming language that only uses parentheses. It's called Racket. It's a very fancy language, and it's very different to what you know so far for sure. All right. So read those 2 things, those little 2 sections, not too long, and do exercise 2 and give me a screenshot of that. So if you've programmed before, do this. It's essentially a Hello World program, but you have to like install Racket and get all this stuff working first, and so it'll take a while to read all that. So I think that'll be fair. That's your assignment, all right? And give me a screenshot that you did exercise 2, okay? If you have programmed before and you don't want to learn Racket, I just need to give you some sort of assignment that will take you an equal amount of time to the students who have never programmed before. So if you would like a custom programming assignment for just you, come talk to me and we will figure something out for you. My only requirement is that you learn something you've never learned before. That's what this class is for, okay? So you get better. So yeah, that's my goal. That is everything that I wanted to say. That's your first programming assignment, and I think we all know what we're doing now. We good? All right, so that is officially all that I wanted to say